Hello everyone, hope you all are doing well. As previously I have explained to you how to design a bolt with square threads in CATIA V5. In this video I am gonna be explaining you how to design a bolt with trapezoidal threads in CATIA V5. So before we go into actual designing process, let me explain you some features that make it different from a square thread. So it was the cross section of square thread, and this is how a trapezoidal thread looks like. So in square threads the tooth angle was 90 degree. Here the angle is 30 degree, clearly shown here. And one difference you can just to visualize here is it that the thickness at the base is more for this tooth, so that means it's gonna be stronger. First point. The another thing is it that these are less efficient than square thread. And why does it happen? This happens because of the radial pressure or the bursting pressure it applies on the nut. So whenever we tight them, there is some kind of pressure that goes that actually reduces the tightening torques for this bolt wherever we are tightening this. Suppose we are tightening this with a nut, and at that time what actually happens that we are applying it with a torque, and we are also applying the same torque in the square threads. Then some of the torque is gonna be reduced by the radial force that is coming here because of this tooth profile. So this is why these are less efficient than compared to square thread, but stronger compared to these square threads. So when I tried to look for a drawing sheet for the complete bolt, I did not find any drawing which gives me every detail about these trapezoidal threaded bolts, but this is what I find here. And I think the tooth profile is most important thing, so I will gonna design this thing, and the dimensions are gonna be considered from this image here. The most important thing about the profile is this 30-degree angle and this height, this width. So here all values are here, and the drawing what I have drawn by myself is it, and this is d1, this is d2. I have considered these values by myself. You cannot find it. I do not think you can ever find this in real designing process. Maybe you find, or you cannot, I don't care, but these are the values I have considered for this bolt, overall bolt, and I do not think these are most important thing. The most important thing is this tooth profile, what I have considered seriously according to the previous image, this one, the h1, the height of tooth, angle 30-degree, height 1.866 p. P stands for pitch, and I have tried to keep them real. Here you can see the formulas. I have considered d1 is equals to 40 and pitch 5 mm, and then tried to calculate it everything. Now from here you can have two ways to design this type of bolt in CATIA V5. Either you can go with the formulas, or you can go with this direct values. Both are easier. It's nothing like complicated thing to use the formulas there, but for the sake of simplicity right now I will go for these values directly. I will insert these values directly there. So let's get started now. Go to CATIA, start, mechanical design, part design, click OK. Now select this sketch and then select any plane here, XY plane for this video. Click on circle, click on origin, and now the dia, it is gonna be 40 mm as according to the drawing sheet I have considered. Click on exit workbench, click on pad, and the thickness, it is gonna be 20 mm. Just click OK. After that, rotate a bit, click on this another surface. Now bolt head, as I have previously explained all this stuff how to design bolt head, so I'm not gonna be designing any fancy head right now. I'm just trying to save the time. Click on sketch, zoom it a bit, pin it here, click on another circle, and click on constraint. After it, double click here, double click, and this die is gonna be 20. half of the initial dia. Click on exit workbench. The complete shank length, it is going to be 100 mm. Now we will draw the helix on it. Go to start, mechanical design, wireframe and surface design. So we need to draw a point first, as I have already explained these all steps in previous video. Click on sketch. After it, just click on this project 3D elements. So what it actually does is it that it's gonna bring the 2D image of cross sections here. This is what I was required for. Click on point now over this 2D sketch. Now exit workbench. Click on spring. It has already considered the starting point as this point about the axis, as we have designed everything in XY plane. So this center axis, it is going to be Z axis. Click on reverse direction. Pitch, I have considered it 5 mm according to the drawing sheet. Height, it is going to be 80 mm according to the drawing sheet. Click on OK. Okay, it looks good. Now time to give it a trapezoidal thread profile. For that I will create a plane first. Click on plane, click on drop down option, normal to curve, click on helix for this curve, and click on this point we have already created. So click on this plane we have just created, then click on sketch. Now what we are actually gonna do is it that I'm gonna create a trapezoidal profile, and I am gonna revolve that all over this body wherever this helix goes. So I will use slot option for that. I will show you that thing in a bit. So let me show you first the profile. So I will design this portion. So let's do it now. Okay, this is the rough one. I will make it perfect after some time. Now let's take a reference point first. So it is the reference line. Click on it, press Ctrl and click on point. Now click here, make them coincidence. So this is the reference line for me. Now click on constraint, click on first line, press Ctrl, click on another line. You can leave Control now. Right click here, allow symmetry line. Click on this axis line now. Now these two lines, they are perfectly symmetric about this line. This was required, and now let's make it 30 degree as the first features of trapezoidal threads. Now this width, okay, according to the drawing sheet, how much it was this W, and W is 0.366 times of P, and it was 1.83. Let's insert this value 1.83. click enter after it. Now this width, it was delete this, click on constraint, click on these two lines. It was 0.5 of pitch, 0.5 of pitch, that is gonna be 2.5. okay, now click on this outer line and press Ctrl and click on point. Click on this constraint option again, click on coincidence, click OK and minimize it a bit. Now at this point we have created this profile, and it's about to revolve at this helix portions. So before we go into this slot options which is gonna make that thing, let me explain you one thing. Is it that what I feel about slot option here is it that when I am trying to revolve this, what actually happens that maybe this CATIA software, it confuses that this line is not on the outermost surface of this sank, or sometime it creates problem. Let me show you how does it goes. Go to start, mechanical design, part design. Okay, use this slot option here, profile, click the profile you have created. For the center curve, go for the helix, click OK. Now this is what I am talking about, this warning message. Is it that sometime I feel what I feel about this thing is that it confuses if it is the outermost surface or not, so it shows this thing in error form. And even these profiles, these are not the perfect one. You will see there will be some kind of errors in here. Click on slot for more clarification, click on properties, graphics, color, select any random color from here. So you will find that there is some difference here, that all threads, all gaps are not equal. So what I usually do for this problem is it that I go back into the sketch and I remove that confusion. So how I do it, I just extended these things. Okay, and remove this. It is not gonna create any problem here because tooth profile is this portion and I have extended it here. What actually happens that this outer thing from here to here, it is not gonna count that much. Why? Because it is going to revolve on an area where there is no surface. Only area which counts is this thing. So this way CATIA doesn't get any type of confusion out there. Click on exit workbench, and now this time I do not think I will get any type of error message. See, no error message, and these threads are being designed perfectly. Let me zoom it a bit. Here, so now everything looks perfect. Now click on the surface, go to properties, just for visual effects. This is not that much important where the dimensions, click any color. Okay, so this way how we create the trapezoidal threads. Hope you guys liked it. If you have any kind of confusion or you have any drawing sheet and you are not able to design it by yourself, please let me know. Please share this problem with me and I will feel really happy to solve that problem with you. And I hope that you liked this video. If you liked it, please give me a thumbs up. Thank you for watching.